Um, Today we will discuss about some types of mechanics. Already this discussion, the topic of kinetic, it lies under engineering mechanics. Engineering mechanics is a branch of mechanics where we deal with the external effect of the forces. So the effects are maybe in static condition, and if they are in static condition, it is dealt under engineering statics. And if they are moving, the bodies are moving, then it is dealt under the dynamic portion. So if we are interested only in the motion of the bodies or particles without considering the forces, uh, then the important aspect or all these phenomena lies under the umbrella of kinematics, so, which is our topic today. We want to exactly define the kinematics. It is the branch of dynamics which describes the motion of bodies without reference to the forces which either cause motion or generated as a result of motion. It is also called geometry of motion. It is the most important thing that we can plot the motion with the help of some aspects lies under this subject, and that give provide us a better picture and help us in designing of different machines, understanding different mechanism, different phenomena. To better understand the concept of kinematics, let's say we have an object shown here, and if we apply some force, although the force is being not considered in this kinematics, but what happened due to the application of force is important, and the body move like this and strike to an object and change its direction. So this is the important aspect. We are dealing with the motion, how it's happening and how the motion is changing its path due to some external effects or some other things. Whatsoever the case, our focus is over on the particle, how it is moving, how it is changing its path, irrespective what are the forces acting on it for causing the motion, what are the forces causing to the body to change its direction. We don't consider these forces, only the projection, geometry, motion path we will discuss, the motion aspects we will discuss. The most basic type of motion is called rectilinear motion. In this part, what we do that the motion along a line is studied, how object is constrained or restricted to move in a line, like a train which is moving in a line, like you are driving on a road, straight road, and you're bound to drive on that road. So on such aspects, what happens with some basic concepts of motion we will discuss in this section. Maybe there are other types of motion in 2D and 3D. For the time being, we will discuss only the basic type, that is rectilinear motion. Most important aspect in this discussion is that the displacement. Uh, Most of the times we confuse this with the term distance. First of all, distance is a scalar quantity, whereas displacement is the vector quantity. Displacement is the length of the shortest path between 2 points. It is displacement. And distance, it is the length of the path followed from one point to other point. So both are different. Maybe in under some case they are same, but maybe they are not. So we will elaborate the different aspect of displacement in upcoming graphics. To understand the displacement, we will take the example of cycle. Why I have selected the cycle? You know, the day by day the fuel prices are increasing, so it's for cheap for me and easy for me to get a cycle and give some examples by using the cycle. So if a cycle at a some reference point, and then we have started counting over time, and it is moving in a line, and after some time it reaches a point, specific point. Up to that, the time interval was t, and the distance traveled from our reference point was s. Now, after that point, we have taken under consideration the movement of cycle. Although we were observing the cycle, but now we are taking some record, we are noticing the movement, and after some time interval delta t, the cycle reaches to another position, and at that position it cover a displacement of delta s. So the total time up to this was t plus delta t, and the total displacement is s plus delta s. In this case, the displacement is positive, and now we can say that the distance and displacement both are the same. We take another example. The same bicycle is at reference point, and in time t it moves to other point and cover a distance of s. And what happened, maybe due to some reason, the bike slightly moving in the opposite direction. Due to some reason, the biker forget something, or there was some slope and he was unable to ride the cycle on that slope, and after delta time t it reaches to a new position in the same part in reverse direction, and displacement covered is delta s. Now the total time was t plus delta t, and total displacement will be s minus delta s. Now in this case, the displacement is s minus delta s, whereas the distance will be s plus delta s, because I have already explained displacement is the shortest length of the shortest path between 2 points, whereas the distance is the length of the path followed by. So the length of the path was that it was moving first in some direction, it moved to what that point is s, and then comes back as delta s, so it travel s plus delta s. But what was the displacement where it was done? It was s minus delta s. I hope you have a clear understanding about this concept. After displacement, if you have a very clear understanding about the displacement, then come another concept of velocity. Velocity is also a vector quantity, whereas speed, opposite to that, is a scalar quantity. We can say that maybe in rough an idea that the magnitude of velocity may be called as speed, but not exactly. When you're driving a car or another vehicle, bike, there is some speed mentioned. That was the speedometer. It is not the velocity meter, because it only shows the magnitude, how much distance is covered in how much time, and doesn't matter what is the direction of it. But when we are talking about the kinematics, the most important thing is velocity. So what is velocity? The change of displacement over change of time, and the time may be taken as very small interval of time if we are very careful in studying, and sometimes we apply the concept of limit that time approaches to zero, and we call that instantaneous velocity. This concept we have studied already in your 10th or 12th grade. So another form to write the velocity is this, that velocity is equal to s dot, where dot mention the first derivative. Then come the acceleration. Acceleration is a very, very important thing. Why it is important? That imagine when you drive something, especially on bike or car, and you have an accelerator there available in bike or car, and you press more pressure on accelerator, and the bike or the car is moving very, very fast. So that feeling, the velocity was not too high, means if you look at the speedometer, if you're moving on a straight road, maybe the speed indicated is like 30 kilometer per hour, 40 kilometer per hour, but you feel a higher pressure because of acceleration. And after some time, when you smoothen your accelerator at some specific level, and even the velocity is 100 kilometer or 120 kilometer per hour if you're traveling on a straight road, still you're not feeling the same air pressure as you were feeling acceleration. It is because of acceleration. When you have constant acceleration, it means the speed should be increasing. And when the velocity, or you can say that the uh, reading on your speedometer is constant, it means the acceleration is zero now. This is the uh, and relationship, or betterly we can write it on v dot or s double dot, means second derivative. I again request to people that you should have a clear concept of acceleration, zero acceleration, and this. Constant acceleration means the velocity is increasing gradually. Uh, there was a very famous movie, Top Gun, and in that they had mentioned that the speed is approaching to 5G, 7G, 8G, 9G, and so on. What is that G? It was gravitational acceleration. It was not the speed, it was the acceleration, that the rate of change of velocity. The aircraft was moving very fast, and we assume that the gravitational acceleration is 10 meter per second square. So 1G means the change of velocity in 1 second will be 10 meter per second. And if it approaches to 9G, it means the change of velocity will be 90 meter per second in 1 second. So if an object is traveling to a condition of 9G, it means every second the velocity will increase to 90 meter per second. Like at in start it will be zero, after 1 second it is 90 meter per second the velocity, after 2 seconds it is 180, after 3 seconds, and after 10 seconds it was 90 900. So it's very very high velocity, and that condition is very tough. And you can, if you seen the that movie, and you can find the clip on YouTube about 8G 9G condition, you can observe how much pressure the aircraft was feeling. Another useful relationship is VdV is equal to AdS, or we can write, V velocity is the first derivative of displacement and acceleration is the second derivative. We can write in this way. These equations are very helpful in solving the problems of rectilinear motion under the concept of kinematics. If you want to have a clear concept of graphical relationship of velocity, you can see a motion of a body was tracked at time t1 it is at that place, and at time t2 it was at other place, and this is st diagram. In this case, the velocity at any specific time t is the tangent to the curve, that is ds over dt. This is another graphical relationship, good for you people to understand, to visualize the motion. Second thing is that if we draw a diagram of velocity with respect to time, it may look like this. And if we are interested that at time t1 from time t2, what's happening? So we can have this equation that basically it is derived from velocity concept. The velocity is ds over dt, or we can rearrange this as ds is equal to v dt. And when we apply limits, that from S1 to S2 point, the body reaches in time T1 to T2 under this specific condition, it will be the area under the VT curve, means from not the highlighted area, from time T1 to time T2. Uh, you can project and use your mindset that how we can draw this graph, this type of equation on graph paper, and then you can count the number of blocks in the graph paper, and then the number of graphs small box under the curve will result to the same S1 S2 condition. Maybe later on we will discuss or practically do this type of calculation. Relationship about the acceleration which was rearranged, and when velocity reaches from v2 and v1 from t1 to t2, it is the area under AT curve. Why we are discussing these? Because it will be helpful for finding the equation of motion and understanding the behavior of motion. That's why these curves are important. Maybe after solving some numericals, your concept will be more clear about these graphs. Similarly, we can develop a relationship between acceleration and displacement, and we will have such type of equation. By using the condition of initial velocity to a final velocity, initial displacement to final displacement, and time 0 to time any time t, we can use the previous equation to drive these equation of motion. So these are some very basic concept of kinematics. In our next video, we will discuss how we can understand the motion of the particle. Thank you very much. If you like, please subscribe to my channel.